Hi there, welcome back to the channel. Now let's solve differentiation of parametric equations. So how do you differentiate parametric equations? You could want to differentiate in the first order or the second order. I will do the first order in this video, but I'll show you the method for both orders, first and second order derivatives. You can also do for higher orders if you want, but I'm just going to be doing for first and second orders, which are the most commonly asked questions. Alright, so the formula is your dy dx is going to be equal to, you first have to find what is called, you have to first find dy dt, that is, because I'm using t because my equation is with respect to t. If my parameter is theta, then it will be dy d theta. If my parameter is a, it will be dy dA. Does that make sense? So my parameter here is t. So, okay, theta here, so I'll have to use the theta in that equation. Does that make sense? So first find dy dt, as I said before, then also find dx dt. So after finding these two, then you now say dy dx, which is your first degree derivative, will be dy dt dot, you will invert this, right? This one will come down, this one will go up, that becomes dt dx. So and that will be your answer. What if that's for first degree? But if you want to find for second degree, now what you do is this, that's for d squared y dx squared. What you do is you first find the dy dx dt. What that means is that you are going to differentiate your dy dx that you first found here. You would have done the first degree, so then you will now find the derivative of that with respect to t again, so dt to t again here. Then the second step will now be to multiply this, that is the dy dx dt by dt dx. Does that make sense? So this is the step. Okay, so let me show you how to first solve these questions by first degree. So the first question says, it says y is equal to that. So since y is equal to t squared, then dy dt will be equal to 2t, right? Very simple. Then x is equal to t cubed. So dx dt will be equal to 3t squared. That makes sense here. So what you want to do is now find dy dx according to the equation I gave you just now. That will be dx dy dt dot dt dx. Okay, so our dy dt is 2t rather, multiplied by dt dx. Now that will be inverse of this. Dt dx is going to be 1 over this if dx dt is 3t squared. Hope that makes sense. So dy dx therefore will be equal to 2t over 3t squared. So this takes care of 1, then we have our dy dx equals 2 over 3t. So if you wanted to go a step further, you just find this dt. Does that make sense? And you now multiply it by dx dt again, and then you get your answer. All right, so this will be the answer for the first one. And the second one says y equals 2 sine theta. So our parameter is theta here, and x is equal to 3 cos theta. Okay, so here to find, we'll first find dy d theta here. Okay, constant, you don't differentiate constant here. Derivative of sine x is sine theta is cos theta. Then dx d theta here will be equal to 3. Derivative of cos x is negative sine theta here. So this becomes minus 3 sine theta. I just wanted to conserve space. So dy dx will now be equal to dy d theta dot d theta dx. Okay, so from here we already know that d theta dx will be 1 over this, right? Inverse of that. Just turn it upside down. This thing is over 1, turn it upside down. I hope that is not confusing. So dy d theta becomes 2 cos theta multiplied by the inverse of this. Let me just put that so that for people that might be confused, since this is equal to minus 3 sine theta over 1, then the theta dx, by the time I reverse this, I also reverse this. Does that make sense? So that's what I've been trying to say. So it means that I'll multiply this guy by 1 over minus 3 sine theta. So our dy dx therefore becomes 2 cos theta over minus 3 sine theta. Okay, and you know that sine theta over cos theta is tan, right? Sine theta over cos theta is tan. So inverse tan is cot, right? Cotangent. 1 over tan is cot. So and 1 over tan is cos over sine. Okay? So therefore we can say that our dy dx therefore becomes minus 1 over 3 cot theta. There's no power there. So cot theta. So this is going to be our answer. So let's solve number 3. It says y is equal to t squared over 1 plus t squared, and x is equal to 1 minus t squared over 1 plus t squared. Okay? So to find the y dt, we use quotient rule, and that will be v du dx minus u dv dx over v squared. So our v, if you don't understand what I did here, just see all the methods of differentiation that I've taught before. I'll try and link the video in the description. So dy dt will be equal to v, which is this guy, 1 plus t squared, differentiate, you hold v, differentiate the top, that is dt squared dt minus, now you hold u, t squared, and differentiate the bottom, right? The t squared d1 plus t squared dt all over 1 plus t, the bottom squared, right? So you hear the bottom, the top minus top, the bottom squared over bottom squared. So dy dt is equal to 1 plus t squared. The t squared is going to be what? 2t, right? Minus t squared. This one, by the time you differentiate, you will get t squared as well. T squared as well. I mean t as well. 2t rather. 2t as well. So you have over 1 plus t squared all squared. Okay, so by the time we multiply this, we're going to get 2t multiply this will give us 2t plus 2t cubed, then minus 2t cubed all over, that's dy dt, all over our 1 plus t squared all squared. So this takes care of this, and dy dt will be equal to 2t over 1 plus t squared all squared. Okay, so let's hold this. And let's go and differentiate our second guy. So we have x is equal to 1 minus t squared over 1 plus t squared. Okay, so dx dt will now be equal to, bottom the top, that will be 1 plus t squared d1 minus t squared dt minus top the bottom 1 minus t squared d1 plus t squared dt over bottom squared 1 plus t squared all squared. This is what we had before too, 1 plus t squared all squared. Okay, so dx dt will now be equal to 1 plus t squared, this gives us minus 2t, right? So times minus 2t minus 1 minus t squared, this gives us 2t. Okay, so let's do the numerator alone, because of the space. So the numerator alone will now be 1 plus, by the time you multiply this, it gives us minus 2t, then minus 2t cubed, then minus, open bracket, 1 minus t squared. No, this one should open the bracket here, so this inner bracket. So we have minus, so we have 2t rather, minus 2t cubed. Okay, so the numerator still now becomes minus 2t minus 2t cubed minus 2t plus 2t cubed. So this takes care of this, and our numerator becomes minus 4t over denominator. So our dx dt now becomes minus 4t over 1 plus t squared all squared. So our dy dx, recall that dy dx is dy dt dx dt dx. Okay, so dy dt, which we got 2t over 1 plus t squared all squared dot dt d. Now dt dx will be inverse of this, right? That will be 1 plus, okay, so this cancels out over minus 4t. So this takes care of this. And then we, okay, 2 here 1, 2 here 2, tt. So our answer is equal to 1 minus 1 over 2. So that will be it for this video. Do well to subscribe to the channel and click the bell notification to get notified whenever I drop a new video. Also make sure you see the second order where we'll solve further parametric differentiations. God bless you.